All right, let's talk about a question that seems super simple, but actually opens up this incredible rabbit hole in mathematics. What is 0 to the power of 0? Let's dive in.
Okay, so what do you think? What's your gut reaction to that question? For a lot of people, a specific number probably pops into their head right away. Let's start there. Let's build the case for what seems like the most intuitive answer.
You know, a lot of the time in math, the best way to figure something out is just to look for a pattern. So let's do that. We'll start with a nice simple number. How about 2?
Okay, so check this out. We've got 2 cubed is 8. 2 squared is 4. 2 to the first is 2. See the pattern? Every single time we drop the exponent by 1, we're just dividing the result by 2. It's a really clear, predictable path, right? So what comes next?
Well, if we follow the pattern, 2 divided by 2 is 1. And this points to a really simple, elegant rule, doesn't it? It seems like any number to the power of 0 should be 1. It feels right.
But, and this is a big but, as the source material points out, a pattern, well, it's not a proof. It's really convincing, for sure, but it's not a mathematical proof. To make this official, our little rule has to play nicely with all the other established rules of math.
All right, let's put our intuition to the test. Let's see if this holds up using a really core rule of exponents.
So here it is, the division rule for exponents. This thing is like a cornerstone of algebra. And for math to work, for it to be consistent, rules like this have to work all the time. So let's see what happens when we use it on a number divided by itself.
Okay, this is where it gets really cool. On one hand, we know any number divided by itself is just 1. Simple. But on the other hand, the division rule we just saw tells us that the very same thing is equal to that number raised to the power of 0. Since there are two different ways of describing the exact same thing, they have to be equal, right? So a to the power of 0 must be 1. The logic seems absolutely airtight.
So there we have it. Case closed, right? To keep all of math from falling apart, any non-zero number to the power of 0 has to be 1. Did you catch that? I just said non-zero?
Well, yeah, this is where things get weird. Because, 0 has a bit of a reputation in math for being a rule breaker.
So what happens if we try to use that same flawless logic, but we swap out our a for 0?
Okay, let's do it. We apply the rule, we get 0 to the power of n minus n. That simplifies to 0 to the power of 0. Easy enough. So far, so good. That's 1/2 of our equation sorted.
But, and it's a huge but, there's a massive problem with the other side of the equation. Remember the other side? It was just a number divided by itself. So now we've got 0 to the power of n divided by 0 to the power of n, which is just 0 divided by 0. And, well, that's where we hit a brick wall.
Yeah, you can't divide by 0. It's like the number 1 rule you learn in math class, right? It's what's called an indeterminate form. It literally has no defined value. And boom, just like that, our beautiful, perfect proof just completely falls apart. We're stuck in a paradox. One rule is screaming that the answer has to be 1, but a much more fundamental rule is telling us the whole thing is impossible to begin with.
So what do we do? Well, this paradox has basically split the mathematical community, leading to two completely different and valid conclusions.
So you've got these two main camps, right? The first one basically says, look, let's just define it as 1. It's practical, it's useful, and it makes a ton of important formulas work beautifully, especially in areas like algebra. But then you have the other camp, and they're saying, whoa, hold on. This is a crack in the foundation. We have to leave it undefined. Because if you're working in calculus with limits, for example, just assuming it's 1 can lead to some really wrong answers.
And the source material really digs into this debate. It points to papers where brilliant mathematicians argue for both sides. And what that tells us is that this isn't really about finding some single cosmic truth. It's about choosing the most useful definition for what you're trying to do.
So where does that leave us? What's the final answer? The way we resolve this mystery is actually, well, it's less about calculation and more about philosophy.
See, the value of 0 to the power of 0 isn't something we discover, like finding a new planet. It's something we define. It's a convention, an agreement we make because it's useful in a particular situation.
I love how the source puts this. It basically says, I use it as 1 when I need to, and I use it as something else when I need to. The correct answer completely depends on the context. There's no single answer that works everywhere.
Think about it like this. If you're a computer scientist building a programming language, you'll probably just define it as 0 because it makes your algorithm simple and consistent. But if you're a calculus professor, you'll tell your students it's an indeterminate form because when you're dealing with the concept of limits, you have to be way more careful. And you know what? They're both right in their own worlds.
And that leaves us with a really fascinating thought, doesn't it? It shows that math isn't always this rigid set of absolute eternal truths. In some ways, it's a creative language that we humans have built, full of useful agreements and conventions. So maybe the big takeaway here is that sometimes in math, the most important question isn't what's the answer, it's why are we even asking the question?